Okay, well, we are back for our second lesson in our transformations unit, and this one is all about, if I could write, reflections. And we have a little thing for you here. Transform his ways! We are lousy singers.
That's why we better keep our day job, Mr.
Yeah,
Cass.
absolutely. Make a change. I like that. That's what reflections are all about, making changes. And let's write down that definition here. A reflection, sorry, I'm just laughing at our singing. A reflection is a mirror image of the original figure.
Remember, we called that one the pre-image.
That's right. So the pre-image is the original figure, and then the reflection would be the image. There we go. Okay. Perfect. Now, let's see where we're going here. So reflections are, see this. It is the result of a transformation. Of a figure over a line called the line of reflection. The line of reflection. Now, I think we have some examples of how that would look, don't we?
Yeah, we found some on the internet.
Yeah, let's look at this first one, and this first one is going to be over the x-axis, I believe?
Yes, that one's the x-axis.
This is the x-axis, so let's see what this looks like.
Let's make that a little bigger.
Oh, okay, we can do that.
Awesome, now even I can see it.
So this is an example of how a reflection would be over the x-axis, because if we look at it, this would be the x-axis. Oops, I think I cut his paw off a little bit. That's okay. But you get the idea that it's a reflection. Watch this little neat thing here. I'm going to do, come on. There we go, pointer. So I can take the image, the pre-image is the cat, and reflecting it over the x-axis gives me the image or that reflection there.
Can I point out one thing that
Sure.
I always think is really cool? So from this is a little bit high, this x-axis here. It should be more down here at the bottom of his paw. But each point is equidistant. His eye is the same distance from the point of reflection or the line of reflection from his eye. They're equidistant. So that's what happens when you look in a mirror. As far away as you stand from a mirror, that's how far away the image looks from the other side of the mirror.
Oh, okay. Now, we know that the x-axis, but we also know that we can do the y-axis. And let's take a look at that for a second. Let's get a picture in here. And here would be one where the reflection is the y-axis. And I see what you're talking about, because if I look at the distance from the edge of her eye to the edge of their eye, and I kind of break that in half, this distance from the y-axis to this distance on the y-axis will be exactly the same.
Exactly.
Okay, I get it. There we go. We're having computer problems, so we might say something again to you, but that's okay, because I think we're going to show you an example, and I think it's Mrs. DeMix going to show you this example, but I hit the wrong plus button before, because what I want to do is I want to add
a coordinate plane.
The coordinate plane in. There it is.
Beautiful.
There's the coordinate plane. Okay, so here we go, and we can make that about
that way I have
that
some writing
big.
room.
There you go. So let's see how this works with the coordinate plane.
Okay, so remember we're going to start with a pre-image and we are going to be graphing the image. So I need to start with my points. Let's see, we're going to say point A. I need to grab my pen. Point A is at -5, 1. And we're going to be reflecting him across the y-axis for this first problem. And I have my point B, which is going to be at negative 3, 2. And C is going to be at negative 1, negative 2. Let me go ahead and graph those. You can't see, I don't have my thing where you can see, but I'm going to go ahead and move my pen across. I'm going backwards from the origin. Negative 1, 2, 3, 4, 5, and up 1. And there is the point A. Please make it a good habit to get those all labeled. It helps out later when you're doing your thinking, and it just really helps label those points. And now I'm going to do negative 3, positive 2. This is point B. And then C is negative 1, negative 2. So we've got a polygon called a triangle. There we go. So that is the pre-image, the original, and we are reflecting across the y-axis. Okay, so I'm going to just go ahead and highlight that here. This is the y-axis. Hopefully you can see that. So it's going to be like our shape, triangle ABC, is looking into a mirror, and each point will be exactly the same distance, but on the other side. So if this is, I'm going to start with point B, even though it's not A.
Because it's easiest.
Because it's the closest to the axis, it actually makes it easiest,
There
you're
you
right.
go.
So I'm going to count backwards 3. So to do that, I can count forwards 3. And that's where I'm going to find B prime, right there on the corner. It's going a little higher than I want, right on the corner there. And then C is 1 away from the y-axis. So it's going to go right across here, C prime. And the hardest one is the one furthest away. I have to count the biggest. I have to count to 1, 2, 3, 4, 5. So you know that counting to 5 is much harder. 1, 2, 3, 4, 5 in the positive direction. And I've got A prime. And I go ahead and I connect those. And now I have the pre-image, triangle ABC, and the image, triangle A prime, B prime, C prime. And that's how you graph a reflection across the y-axis.
So I think we should do this. You showed them how to do a y-axis, and the x-axis should be the same, right?
It's very similar.
Should be very similar. So let's do this. Let's give them some points here. I'm going to give them the point 4, 2. 1, 2, 3, 4, and go up 2. So this is point A, and point A is the point 4, 2. And B is the point 2, 3. There's B. So B is the point 2, 3. And C is going to be the point negative 2, 1. Negative 2, 1. So this is going to be C. So here is my pre-image. I want to reflect this. I'm going to reflect this over the x-axis. And I want to see if you can do this first. So I want you to pause the video and see if you could figure out how to reflect that over the x-axis using the same technique that Mrs. Dimick did on the y-axis. So pause the video, try it, and then we'll come back and we'll see how you did. All right, let's see how you did. If you did it right, you would have taken point A, which was up 2, and you would have gone down 2 to get A prime, because I want to do it over the x-axis. For B, it was up 3, so I'm going to go down 3, and that's going to give me my B prime. And C was only up 1, so we'll go down 1 to get my C prime, and there is my reflected triangle over the x-axis.
And I love how you labeled everything. That's very important, Mr. Cass.
It is so important because sometimes these things get really crazy and overlap each other, so you really got to know where your points are. I think there's another one we got to look at with them. And this is a tricky one. We're going to give them the points P, which is 3, 1, Q, which is 2, negative 2, and R, which is negative 1, 3. And here's the thing with this one. I want to reflect these over the line x equals 1.
I remember that. That's one of those straight line equations. I remember those.
That is one of the straight line equations, and we'll get them started with that part of it, but I think what we need to do is let them graph the pre-image, and then try to reflect it. And I think this is the question that they need to call us over for and ask us if it's correct for the ending of this video.
Excellent idea.
But let's help them with the x equals 1, because that's the tricky part, is where is x equals 1? And we know that x always has to be 1.
Yeah, no matter what y
No
is.
matter what the y is, x always has to be 1. So what we're talking about is and I'm doing this with a thick highlighter,
Even I can see that.
but that is my x equals 1 line, because x will always be 1 no matter what point I pick
Yeah.
for y.
When y is 0, x equals 1. When y is 5, x equals 1. X just always equals 1 on that line.
All right, so remember to call us over when you have an answer to that last problem, but before we go, we thought we would leave you with this. There we go. We're going to put a grid on here. Large the grid. And then we're going to add. Try to do as fast as I can.
You're doing great. Plus, I'm enjoying the song. So there's Optimus Prime in quadrant 2. So what's he going to look like if we transform him, reflect him across the y-axis? Oops, that's not it. Oh,
Oh, you know what? We rotated him instead of, it'd be this way.
Oh, good. Oh, good. And keep him the same size. We're going to learn about changing size later, Mr. Cass.
I know, so we'll keep him the same size.
Now, is he the same distance from the x-axis as the other one? Let's move him down. Oh, I like that. Good.
There
So
we
there's
go.
Optimus reflected from quadrant 2 to quadrant 3. Can we keep going?
We can. I don't know how we'll do this, but we'll see if we can do it.
Hey, we're learning. They're
We're
learning.
learning. Yeah, we're just having fun playing around with this, with the pictures. I think what I'm going to do is take this picture, and I might have to do something that we're going to learn a little later, but nope, that gives them the same way, doesn't it?
It does,
That
yeah.
was not a good picture. Wrong picture to use.
Oh, but you know why? I think I know what happened. We might not be able to do it in all 4 quadrants right now.
We may not be able
because
to.
we rotated him clockwise on our computer, but we didn't actually reflect him.
We didn't reflect him. We just
Yeah.
rotated him.
Well, there we go.
You get the idea, guys. Anyways, that ends this video, and we will see you in class.